For over 400 years, astronomers have been staring at our own galaxy completely blind. We thought we knew the Milky Way. We were wrong. Hidden behind cosmic dust clouds, millions of stars have been invisible to us. Entire spiral arms, secret star factories, the true shape of our cosmic home. But now, revolutionary infrared technology has ripped away the veil. We'll journey through hidden stellar nurseries where giants are born. Discover the galaxy's violent past written in starlight and uncover how our cosmic address just got rewritten. If you're ready to see our galaxy like never before, hit that like button and subscribe. The revelation begins now. Music. Imagine trying to map your house while standing the problem inside a thick fog. That's exactly the problem astronomers have faced for centuries when studying our own galaxy. We live inside the Milky Way, embedded deep within its disk, surrounded by stars and cosmic debris that block our view. It's like being a single person standing in the middle of Times Square during a snowstorm trying to draw a map of New York City. When Galileo first pointed his telescope at the night sky in 609, he saw the Milky Way's cloudy band resolve into countless individual stars. But he had no idea he was looking at the edge on view of a massive spiral galaxy. No idea that our sun was just one ordinary star among 400 billion others. No idea that we were spinning through space at 500,000 miles an hour, trapped in a cosmic whirlpool larger than anything humans had ever imagined. For the next 3 centuries, astronomers tried to piece together our galaxy's structure using visible light alone. They mapped where stars appeared brightest and where they seemed to fade away. They counted stellar densities in different directions. They measured how stars moved through space. But every observation was fundamentally limited by the same cruel fact. Visible light can't travel very far through the galaxy before something blocks it. Think of it like trying to see across a crowded stadium during a fog machine concert. The lights are there, but layers of haze keep you from seeing the back rows. In space, that haze is cosmic dust. Tiny particles of silicon, carbon, and iron scattered throughout the galaxy like microscopic sand. These dust grains are so small that 10,000 of them lined up wouldn't span the width of a human hair. Yet, they're everywhere, floating between the stars in vast clouds that stretch for hundreds of light years. The dust doesn't just dim starlight, it completely blocks it. A dust cloud, only a few light years thick, can hide an entire star cluster containing thousands of suns. Some of the most massive stars in our galaxy, giants that burn 1,000,000 times brighter than our sun, remain completely invisible to optical telescopes because they're hidden behind these cosmic curtains. By the 1950s, astronomers realized they had mapped less than 10% of the Milky Way. The other 90% remained hidden behind dust. They could see individual stars within a few thousand light-years of Earth. But beyond that, their view was blocked. They were like archaeologists trying to study an ancient city while wearing blindfolds, feeling around in the dark for clues about what lay buried beneath. The galaxy's true spiral arms, its central black hole, its complete population of stars, the secret stellar nurseries where new suns are born. All of it remained shrouded in mystery. We knew we lived in a spiral galaxy because we could study distant galaxies that looked similar to what we thought ours might look like. But we were guessing about our own cosmic home. What astronomers needed was a way to see through the dust entirely. They needed a different kind of light that could pierce the cosmic fog and reveal what had been hidden for so long. But what kind of light could possibly penetrate clouds so thick they had fooled humanity for centuries? Cosmic dust isn't like the dust bunnies under your bed. These microscopic particles are the cremated remains of ancient stars scattered across space in clouds so vast they could swallow our entire solar system and still have room for 1,000 more. When massive stars die in supernova explosions, they blast their guts across hundreds of light years, seeding space with silicon, carbon, oxygen, and iron. Over millions of years, these particles clump together into the cosmic equivalent of smoke clouds, floating between the stars like ghosts of stellar death. Each dust grain is smaller than the particles in cigarette smoke. You could fit 50,000 of them across the period at the end of this sentence. But what they lack in size, they make up for in sheer quantity. Our galaxy contains enough cosmic dust to build 10 million planets the size of Earth. If you could gather all the dust in the Milky Way into one place, it would outweigh our sun by several times over. The problem isn't just how much dust there is. It's where the dust likes to hang out. Cosmic dust gravitates toward the galaxy's disk, the same flat plane where most stars live, including our sun. Think of a snow globe that's been shaken and then left to settle. All the artificial snow sinks to the bottom, creating a layer that blocks your view across the globe. That's exactly what happens in our galaxy, except the snow is cosmic dust, and the globe is 400 billion stars spinning through space. From our position inside the galactic disk, we're surrounded by this dust. When we look toward the center of the galaxy, we're staring through thousands of light years of accumulated particles. When we look along the galaxy's spiral arms, the dust is so thick, it's like trying to see through chocolate milk. Only when we look up or down out of the galactic plane can we see clearly into intergalactic space. That's why we can cosmic dust observe distant galaxies billions of light years away, but we can't see what's happening in our own galactic backyard. The dust affects different colors of light in different ways. Blue light gets scattered and absorbed much more easily than red light, which is why sunsets look red when viewed through Earth's dusty atmosphere. In space, this means blue stars become invisible long before red stars do. But even red light can only travel so far before the cumulative effect of countless dust grains blocks it completely. By the middle of the 20th century, astronomers had mapped the dust's distribution and realized the full scope of their problem. They could see roughly 5,000 light-year in most directions before cosmic dust made further observation impossible. But the Milky Way stretches over 100,000 light-year from edge to edge. They were seeing less than 5% of their own galaxy. The dust had created the ultimate cosmic conspiracy, hiding the galaxy's secrets in plain sight. Star clusters containing hundreds of thousands of suns remained completely invisible. Entire spiral arms disappeared behind dusty veils. The galaxy's most active star-forming regions, where cosmic creation happens on an industrial scale, were locked away behind impenetrable barriers. But astronomers were about to discover that dust, for all its power to block visible light, had one critical weakness. The cosmic dust that had fooled humanity for centuries had never encountered infrared light. Infrared radiation is invisible to human eyes, but it's everywhere around us. Your warm coffee mug emits infrared light. Your body radiates infrared energy. Even ice cubes glow brightly in infrared wavelengths. This thermal radiation carries a wavelength roughly 10 times longer than visible light. And that difference changes everything when it comes to cosmic dust. Think of trying to throw basketballs versus ping pong balls through a chain link fence. The ping pong balls get blocked and bounce off the wires, but the basketballs sail right through the gaps. Infrared light behaves like those basketballs. Its longer wavelength allows it to slip past dust particles that easily block visible light where visible light sees an impenetrable wall. Infrared light sees open highway. The breakthrough came in the 1960s when astronomers launched the first infrared telescopes above Earth's atmosphere. Our planet's atmosphere absorbs most infrared radiation. So, ground-based infrared astronomy was nearly impossible. But from space, infrared detectors could peer through the galaxy's dusty veil for the first time in human history. What they discovered was revolutionary. Stars that were completely invisible to optical telescopes blazed like beacons in infrared light. Dust clouds that had blocked visible light for millions of years became transparent, revealing the stellar treasures hidden within. Entire star-forming regions shrouded since the galaxy's birth suddenly became accessible to human observation. The effect was so dramatic, it was like someone had switched on cosmic X-ray vision. Astronomers could finally see through the galaxy's walls. The central regions of the Milky Way, hidden behind 26,000 light-years of dust, became visible for the first time. The galaxy's spiral arms, invisible in optical light, emerged from their dusty cocoons. Star clusters containing hundreds of thousands of suns materialized out of what had appeared to be empty space. But infrared light revealed more than just hidden stars. The dust itself began to glow. When cosmic dust absorbs visible and ultraviolet light from nearby stars, it heats up and rewrites that energy as infrared light. This meant astronomers could map the dust clouds themselves, seeing their intricate structure in exquisite detail. They could trace how gas and dust flow through the galaxy, how it clumps together to form new stars, and how stellar explosions blast it back into space. The revelation was like discovering that your house had secret rooms you never knew existed. The Milky Way wasn't the galaxy astronomers thought they'd have been studying for 4 centuries. It was larger, more complex, dynamic, and filled with structures that had been completely invisible. The population of stars was far greater than anyone had imagined. The galaxy's spiral pattern was more intricate and beautiful than optical observations had suggested. By the turn of the 21st century, infrared astronomy had opened new windows into the cosmic deep. But the VIST technology was still limited. Early infrared surveys could only map small patches of sky at relatively low resolution. What astronomers really needed was a systematic, comprehensive infrared survey of the entire galaxy. What they needed was a revolutionary telescope that could map our cosmic neighborhood with unprecedented detail and precision. High in Chile's Atacama Desert sits a telescope that can see what 4 centuries of astronomy could not. VISTA, the Visible and Infrared Survey Telescope for Astronomy, perches on a mountaintop 2.5 miles above sea level, where the air is so thin and dry that infrared light from space can reach Earth virtually unfiltered. This 4 meters mirror, wider than a compact car, represents the largest infrared survey telescope ever built. But size alone isn't what makes VISTA revolutionary. It's what the telescope can do with that massive mirror that changes everything. VISTA doesn't just take pretty pictures of individual cosmic objects. It systematically maps enormous swaths of sky with the precision of a cosmic photographer. Think of the difference between taking a single photograph of your neighborhood versus flying a drone equipped with high-resolution cameras over your entire city. Photographing every building, every street, every park, and then stitching millions of images together into one comprehensive map. That's what VIST does for our galaxy. The telescope's secret weapon is its camera, a marvel of engineering, containing 67 infrared detectors cooled to -300 degrees F. At these frigid temperatures, the detectors become sensitive enough to capture individual photons that have traveled thousands of light years through space, dodging dust clouds and navigating the galaxy's magnetic fields before arriving at Earth. Each detector is more sensitive than the most advanced night vision goggles, capable of seeing infrared sources millions of times fainter than what the human eye can detect. But VISTA's true genius lies in its systematic approach. Rather than randomly pointing at interesting objects, the telescope follows carefully planned survey strategies that map specific regions of the galaxy in multiple infrared wavelengths. It's like having superhuman vision that can switch between different types of X-ray vision, each revealing different aspects of the same cosmic landscape. Some wavelengths reveal hot young stars. Others highlight cool, old giants. Still others trace the warm glow of cosmic dust itself. The VISTA variables in the Via Lacta survey, known as VVV, has spent over a decade photographing the most dust-obscured regions of our galaxy. Night after night, VISTA returns to the same patches of sky, building up incredibly detailed infrared portraits of stellar neighborhoods that have never been clearly seen before. The telescope captures so much data that it fills computer hard drives faster than astronomers can analyze it. Each VISTA image contains roughly 67 million individual measurements of starlight. A single night of observing generates enough data to keep astronomers busy for months. The survey has now accumulated over 500 terab of infrared imagery, creating the most detailed infrared atlas of the Milky Way ever assembled. That's enough data to fill more than 100,000 DVDs stacked 2 miles high. This systematic approach has allowed astronomers to create the first truly comprehensive three-dimensional map of our galaxy's hidden architecture. For the first time in human history, we can see the Milky Way's complete structure from its innermost regions to its outermost spiral arms. And what Vista found hiding in those cosmic shadows would rewrite our understanding of how many stars our galaxy actually contains. Within weeks of beginning its survey, Vista discovered 96 star clusters that had been hiding in plain sight. These weren't small groups of a few dozen stars scattered randomly through space. These were massive stellar cities, each containing thousands or tens of thousands of stars bound together by gravity. Some older than complex life on Earth. They had been sitting there all along, invisible to every optical telescope ever built, waiting patiently for infrared eyes to finally see them. Star clusters are like stellar families, born together from the same cosmic cloud and aging together over millions or billions of years. When astronomers find a cluster, they're discovering a complete stellar ecosystem with its own history, its own population of different star types, and its own story of cosmic evolution. Finding one new cluster is exciting. Finding nearly 100 in a few months of observation was unprecedented.